So the next problem is summation of mu of d divided by d, where what we have to prove this. So what we have here is let Fn is equal to summation of mu of d divided by d, which is defined as summation of f of d, where d runs over the divisor of n. So clearly Fn is multiplicative, because if you take the GCD of Mn, we have f of Mn is equal to mu of Mn divided by Mn. And since mu is a multiplicative function, this is same as mu of m into mu of n divided by Mn, which is equal to f of m into f of n. So this implies that small f is a multiplicative function. Hence capital F, which is defined as summation of mu f of d, is also multiplicative by the theorem from the beginning of this multiplicative function. So let us express n as a product of k distinct prime powers. So Fn is equal to this, so which can be expressed as, since capital F is multiplicative function, this is same as p2 to the power e2 dash dash f of pk to the power e k. Now let us find out what is f of, now f of pi to the power ei is equal to summation of f of d, where d runs over the divisor of pi to the power ei, which is defined as summation of mu of d divided by d, where d runs over the divisor of pi to the power ei. And this is nothing but mu of 1, the divisors of pi to the power ei are 1 pi dash dash pi to the power ei. So this is equal to mu of 1 divided by 1 plus mu of pi divided by pi plus mu of pi square divided by mu of p by pi plus dash dash dash. But here from this term onwards, the term will be equal 0, because there exists a square which divides this. So you have 1 by 1 plus minus 1 divided by 1 plus 0 plus 0, which is equal to, as you can see here, because there is pi here, so this can be written as 1 minus 1 by pi, which is equal to pi minus 1 divided by pi. Or you can leave it as it is. So therefore in general, f of n, which is defined as f of p1, so f of p1 you replace I by 1, so you have 1 minus 1 by p1. F of p2 will be 1 minus 1 by p2 dash dash into 1 minus 1 by pk. So this complete the proof of that, that is summation of mu of d divided by d is equal to this. I hope it is clear to you. Similarly, with the summation of proof that summation of mu of d into mu of d, where d runs over the divisor of n, is equal to 1 minus p1 into 1 minus p2 dash dash into 1 minus pr. So here the same thing. First of all, you note this as f of n is called summation of mu of d, d runs over the divisor of n. It is called to summation of f of d, where d runs over the divisor of n. For multiplicative, you prove the same method as I have proved in the previous problem. So let us just write down this one. F of n here, let n is equal to p1 to the power e1 dash dash pr to the power e r. F being a multiplicative function, so fn is equal to f of p1 to the power e1 dash dash pr to the power er, which is equal to f of p1 to the power e1 dash dash f of pr to the power er, since capital F is a multiplicative function. So now let us find out what is f of pi to the power ei, which is called summation of f of d, where d runs over the divisor of pi to the power ei, and this is nothing but summation of d into mu of d, where d runs over the divisor of pi to the power ei. So this is equal to 1 into mu of 1 plus pi into mu of pi plus pi square, because the divisors of pi to the power ei are 1 pi square dash dash and pi to the power ei. So here mu of pi square plus dash dash. But from this term onwards, the term will be equal 0. So we have 1 into 1, because mu of 1 is equal to 1 plus pi into minus 1 to the power 1 plus 0 and so on. This will be equal to 1 minus pi. So therefore, name this as equation 1. Therefore, f of n here, which is called f of p1, will be 1 minus p1 f of p2 will be 1 minus p2 dash dash 1 minus p, and so this complete the proof.